In the previous video, I explained how to find the centripetal acceleration of an object moving in a circular path. This is done using the following formula, where the centripetal acceleration is equal to the magnitude of the velocity squared divided by the radius of the circle. From Newton's second law, we know that a net force is equal to an object's mass multiplied by its acceleration. And this can also be applied to centripetal acceleration. Therefore, we can write that the centripetal force is equal to the object's mass times the magnitude of its velocity squared divided by the radius of the circle. The centripetal force always acts in the same direction as the centripetal acceleration. So it's always perpendicular to the velocity vector, and it's always acting towards the center of the circle. Now let's look at the following problem. In this problem, a 2-meter string is attached to an object with a mass of 5 kilograms, and the object is revolved in a horizontal circle. The object makes 2.5 revolutions every second, and you're asked to find the centripetal force. We can solve for centripetal force using the following formula. However, we don't know v, the magnitude of the object's velocity. From the previous video, we know that v is equal to 2 pi times the radius of the circle divided by the period. Reading the problem again, we see that the object makes 2.5 revolutions every second. This is the frequency, and since the period is equal to 1 over the frequency, we can divide 1 by 2.5 to find that the period is equal to 0.4 seconds. This means that it takes 0.4 seconds to make 1 revolution. Now we can plug 0.4 seconds in for t and 2 meters, or the length of the string, in for r. Solving the equation, we find that the magnitude of the velocity, or the speed of the object, is equal to 31.42 meters per second. Now that we have this information, we can solve for the centripetal force. Plugging in the object's mass, the object's speed, and the radius of the circle, or the length of the string, we find that the centripetal force is equal to 2,468 newtons. These are really the only formulas that you need to know for simple centripetal force problems like these. Keep in mind though that the centripetal force will not always be the net force. More complex problems may introduce other forces as well. However, by summing forces and components if necessary, you should be able to solve it just like any other force problem. If this video was helpful, give it a like and consider subscribing to the channel. As always, comment below if you have questions on anything. Thanks for watching.